Today's material is also uploaded to GitHub. So if you want, you can download the folder and run it on your local laptop. I'm going to share my screen for the R script. So before we start, actually let's take a look at the material from yesterday, just a quick review. So yesterday we talked about getting started in R and specifically the different types of operators. Then we talk about the R objects and functions. So in specific, we discussed the vectors and augmented vectors in R, the atomic vector, and then we talk about list, which contains heterogeneous content, and then factors, data, dates and date times, and then we close off with the discussion on tables and data frame. So today, let's continue. So yesterday, we load the package via a different function. So let's take a look at that. We used the, maybe it's not here. So we used the install.packages, and then we used library, the library function to load the package every time we start a new session. So today we're actually doing something differently because there's a lot of packages for today's notebook. So actually we're using Pacman. So Pacman is a package management tool, and it's easier and more intuitive. You can take a look at this one. So it will load all of the packages at once. So the first thing we're going to talk about today is the tidyverse package. So tidyverse is a collection of open source packages for R. It is designed to tidy your data, to make the master data more tidy. So I think it is used a lot in the data cleaning process. Let's actually take a look at these 4 data. So this data actually contains the information for population and cases for different countries in 1999 and 2000. This is like a really short data frame. But for these data frame, some of them are messy and some are tidy. I'm gonna show. Oh yeah. Thanks for uploading the GitHub link. The pack. Explain the statement used to download the Pacman package. Yeah. So here basically, this is the a if statement, and if you have not downloaded Pacman package before, it basically runs the first one, this part, and see if you haven't downloaded before, then it will install this package, and if you have download this package before, there's no need to run this line. It will run this line, but it won't install the package again. Okay. Yeah. So for these data set, for these 5 tables, let's take a look at them. So, which one do you think is the tidy table? You can type the number 1, 2, 3, 4A, 4B in the chat for the one that you think is the tidy table. So this is the first one. For the content, all of these contain similar informations. The cases and population for each country each year. So yeah, let's take a look at it.
Excuse me, Professor Amber. I don't know. Is to say what is the table? I couldn't understand the question.
Oh yeah.
Which
You
one?
can just come. Yeah. So these four tables contain pretty much the same information, the cases and populations. So some of the tables are messy and some are tidy. So we're trying to look at which data set or which table is the messy one and which are the tidy one.
Okay, thank you.
Yeah. Please put your answer in the chat if you, okay, table 1, thank you. 1, okay. 1 and 3. We got a 2. I got 5. Yeah, thanks everyone for putting your answer in the chat box. So actually, only the first table is the tidy table. All of the other 4 tables are messy to some extent. So we'll take a look at each table, every table together. So first table, this one is a tidy data set. Actually, let's take a look at what is a tidy data first. So at tidy data, we have a few rules of what is a tidy data and what is not. So first, each variable in a data set is placed in its own column. And then each observation is in its own row. So that's this, this is what, like one observation, and then this is one column. Also, each value is placed in its own cell. So these are some common rules for what is a tidy data. And for the first data, we can see that each row is an observation for the number of cases and number of population. Let's take a look at the second one, why it is not a tidy table. So here for the second table, there is this column, the type column. It contains 2 different information, cases and population. So actually, the type is not an observation. It is more like an attribute or the variable. So you're not observing it. The actual observation is the count here. That's why this one is not tidy. It contains a lot of these cases population, which should be like the columns. For the third table, this one is pretty similar to the first one. So it is organized by column year. Only the last 2 columns are different. So here it uses a rate, and in the first table, it has 2 columns. So we can use some string syntax to convert this rate column to cases and populations, but it sometimes it's gonna take a few lines of code to do that. And if you only sharing the rate, sometimes it's confusing of what this rate is about. That's why for the data set, we try to not manipulate too much and keep all the cases and population columns. And then let's take a look at the force table. So actually 4A and 4B are separated by cases and population. So 4B is the population data frame and 4A is the cases data frame. So it is not tidy in the sense that these two, if we want to combine them somehow when we do analysis, we have to access both data. So that's going to take some lines of coding to do that. It's not efficient because we can actually organize all the information in the same table instead of using two different tables. There are also repetitive information in the first columns, so the country column. That's why we should think the forest table are not efficient, not tidy, in the sense that the observations are actually separated into two different data frames. Yeah, so after we look at these four tables, this gives us like a sense of why we want to have a tidy data set instead of working with messy data sets. So the tidyverse package is actually built on this idea of making the data set tidy, so it's easier for the analysis. So for tidy data, it also useful in the sense that the data structure in R are actually built upon vectors, and R's operations are optimized to work with vectors. So we can work with tidy data more with the using its vectorized data. So let's take a look at how to make different data tidy using this tidyverse package. So has anyone worked with function gather or spread before? If yes, you can put, oh yeah.
Oh, sorry to interrupt you, Amber. So I just wanted a one sentence like difference between when you say the data is tidy versus the data is messy, meaning that for each data, each information about the data should be in its own vector. Is that what you mean by tidy versus messy? So I just wanted like a simple like way of delineate like thinking about both of them in my mind.
Yeah. So I think if we want to summarize what is tidy, what is messy, one important rule is that we want the observation to be in the row instead of any observation in the column. We want the column to be only the attributes or the variables information. We don't want any variable information to be in the rows. That's why we can always put new observations in the row, like to make it longer if we have more data coming in. So yeah, I think the difference between observation and variable is kind of the main idea of what is tidy and what is messy here. Okay, so let's actually take a look at the table 4a first. So for table 4a, we discussed earlier that it is not a tidy table. So we can actually run this gather function to convert it to a tidy table. So basically we want to convert this table in the form of the first one. So we want to put yeah, that's the difference between tidy and messy. Yeah, thanks. Yeah, for this line, we try to make table 4a in the same format as table 1 in the table 1. So we want to organize here. Actually, let me amend it over here. So table 4a. So we want to have a column of 1999 or 2000. And then in that way, we can put all of the observations in the same column instead of having two columns to represent the information. So gather is like the previous function that you use a lot when we want to convert these a table like for A to a longer table. But I think right now we have a more intuitive version of the gather function, which is pivot longer. So it is called pivot longer because we are trying to increase the number of rows. That's why it is called longer, and decrease the number of columns. So we can take a look at its helper page over here. Yeah, so for pivot longer, it increases the number of rows and decreases the number of columns. So basically, we are converting some of the information in the column to rows. And here are its arguments. So the first argument is columns, and then we have a second argument, names 2 and value 2. So columns are the 2 columns that we want to convert to the row. So we pass the column names 1999 and 2000 as the columns you want to convert to observations. And then the names 2 are the new column name we want to give these 2. So we are actually trying to refine something like this. So we want to make a new column called year, which contains 1999 and 2000. And this is our new column. The values 2 is the values that we want to reorganize into one column. So those actually are this 3x2 table over here that contains the cases information. So these are the values, and we want to convert it to one column only, because once we move 1999 and 2000 to a new column, we can then organize all of these values in one single column. That's why this will be our new column name. So let's actually run this line of code and see what we get here. Oh, close this. So yeah, after running code, we get what we want. So basically we have a new column called year, which we transformed from these 2 columns, and then we can organize all of the observation, so all of the values, into one single column instead of like this 3x2 data frame. So a few functions that will be pretty useful later are the AskNumeric and PassNumber function. So actually, let's run these code and see the difference and similarities when running this. So this is used to convert a string to a numeric, which we might use a lot because sometimes when you read the data set into R, some numbers will be read as characters. So that's we use this the conversion. So if we run the first line, it works fine. It converts this string to 2000. But for the second one, even though it still contains the integers with 2000, because there's a y after that, it will not be read as 2000. But PassNumber is actually a more efficient way of doing it, because all of these 3 are returning 2000. So it reads a string and it extracts the numeric information from that string. So this can avoid a lot of mistakes that during the data collection process, because sometimes people might just put like an extra y or actual a over here. But once we use the PassNumber function, it actually reads to 2000 with no problem. So these are a few examples for pivot longer function of converting a wide data frame to a long data frame. Let's take a look at a few more examples. So this is the billboard data frame. We can see the artist and then the track, and also there are a lot of columns. So it is basically the rank of the artist and track for different weeks. if we take a look at the string of Billboard dataset, we can see that it actually have a lot of columns, but we want to make it longer because these are more observations. We want to make a column that contain the week number so that we can actually organize all of the values into one single column instead of having a data frame that is too wide. So still, like before, we can use the gather function, but this one is a little not that intuitive to use. Since we have the paper longer, we'll start with this one. So as before, we are trying to convert a lot of columns into rows. So these columns that we want to convert to are actually the week information. So all of these columns are the ones we want to convert. A very powerful function here is the start with. So basically, if we use columns equals start with, it looks into all of the columns that has a column name starting with WK. So yeah, it basically looks like all of these, and then it will convert to, and then we use the name2 function. We pass C week into the name2 function so that this is a new name for the column containing all of the week information. And then the values2 is the new column containing the rank information. So those will be the rank, like all of these numbers will be organized into one single column. And then we have one extra argument here, which is values drop an A. So this one actually drops the rows that corresponds to missing values. Let's actually take a look at what this one does. So after running this chunk of code, all of the previous information are reorganized. So the previous wider data frame are converted to this very long data frame. We can see it has like a lot of rows, but it only has 5 columns. So this is the new week column. It contains week 11, week 12, from week 1 till the end of week. And then all of the previous observations of the rank are reorganized into this single column. So if we do not have these values drop an A function over here, let's actually delete it and take a look at what it will look like. If we do not have this information, then some of the rank will be an A. So in this process, actually, we identify a lot of missing values compared with before. Those missing values are not that explicit. That's why in this example, we want to only look at the rows that do not have any missing value. So that's why we use value drop an A equals true. So we can further improve this function to remove the WK in the week column. So this was what we got earlier. However, under the week column, we still get week 1, week 2, and we will only want to have like 1, 2, 3, 4, 5 in this column instead of the actual WK. We can use the name prefix to remove the matching text from the start of each variable name. So basically, it looks into this column and then extract only the information after WK. So after we run this line of code, the week information is reorganized. Oh, actually, this is the previous one. So after we run this, the week information is extracted with only the integer. So basically only the weak number and remove the WK. One issue with this updated data frame is that we can see the type is character instead of integer, even though we know like these are integers but are sorted differently, so it recognizes the character. We might want to change it to the type numeric or integer so that it's easier to work with later. So actually pivot longer has another input that can convert the character to integer. So that is the names transform arguments. So we just need to put as integer and then it will convert this column to a integer. Let's take a look at that. After running this line of code, we can see the weak column are of type integer. This can also be done via another function called list weak equals s dot integer. So these two will return the same data frame. Here, weak is of this column is of type integer. For this one, oh, I think I made a mistake in this function. I'll fix it later. Yeah, there should be that. So these are the pivot longer example on the Billboard dataset. So similar to before, we converted a wide data frame into a longer data frame. So it is easier for further analysis because all of the all of the information for rank is organized into one single column. So now let's take a look at how to convert a long data frame to a wide data frame. So one example for a long data frame is table 2 from earlier. So in this data frame, we said it was messy because this column, the type column, actually contains cases and population information, but these two are not observations. They are more like attributes or variables that should be column. That's why we wanted to convert it to a tidy data set via the pivot wider function. So this function actually converts a long data frame to a wider data frame. Its inputs are similar to before but different. So this one requires two inputs. The first is names from, and second is values from. So the names from arguments actually takes key from the original type column and then creating new columns. So it reads into this column and try to put it as new columns. And then the values from are, it takes this count column. It takes this count column and reorganize the information in this column into two different columns, the cases and populations. So actually, let me run this first. So we can see the difference between these two. So the previous type column has been converted to the cases and population, and then all of these informations under the count column are reorganized into this part. So we didn't lose any information in the process, but we were able to get a more tidy data set with the idea of organizing all of the observations in a single row, and then having the columns as to contain like attributes or variables, if you call them. So the pivot wider function is also has like previous we don't have the pivot wider function, we use the spread function. So this one actually achieves the same goal. However, this one is less intuitive to understand. But if we take a look at it, the key actually we're passing the type column, meaning we want to make this column wider. So we want to extract the information in this column to become new columns later. And then the value are this count column. So we want to convert the information in this column to as the new values. I'm going to pause here and let everyone take a look at these two functions for converting from long to wide and wide to long. Yeah. Kevin, you can unmute yourself.
Thank you, Amber. Just for reference purpose, can you please scroll back when you talk about using the function that converts? Oh, yes, one of these functions. The pass integer function in the scroll up a little bit more. Okay, yeah, it's here. And yeah, it's okay. In a way, it says reader.parseInt. I just thought I should just mention this because in R, sometimes you have the same package or the same function that performs, functions that perform the same thing. So sometimes if you don't pay attention to that, the result might not be exactly what you expected. So for the last billboard, the last mention, the pivot longer, the way it says names transform, then reader pass int integer, it's noteworthy to recognize that the reason why we have that there is that if you don't put the double column twice and put pass int, you might get it just simply says that we are calling the reader function to use it for the pass int. Another function can perform similar you can use another package to perform similar function, but then you might get back a result that you're not expecting. So in order to make sure that you get back the result you're expecting, you are saying that you want the pass int function functionality to come from the reader function, which is a package in R. So I just want to mention that it is worth noting because it can cause error in your analysis. Thank you actually for that.
Yeah, thanks Karen for sharing that. Yeah, I think that happens a lot, especially when you loaded multiple packages and the function names are the same. Yeah. So, Ashley, do you have any questions? If not, I think I'm gonna mute you. Oh, actually, Arvin, can you mute Rashid? I think I'm not a host right now.
Oh, no, you wouldn't. No.
Actually, yeah, James, you can unmute yourself.
Yeah, hi, Amber. So with regards to that same place, when I ran the last billboard, I actually had an error. It did say unexpected symbol in values underscore drop underscore NA.
Well, like, be like,
I'm not sure if there was something I did wrong, but when I ran that chunk, I did get an error.
like, what the heck?
But see, that's kind of
Right. Just like, yeah.
Sorry, let me try to unmute Rishi maybe first. Hey Alvin, can you unmute Rishi?
If I can figure out,
But I think you can multi Rashid by yourself because you are the hoster.
Actually today I'm not the host.
I don't know.
Wow.
I'll invite Nanette here and see if she can do that.
Yes.
Oh, but I was thinking of Rob. You're talking about Rob. I guess, do they even put RA? They probably put Rob.
I mean, it's not far from the possible. It's gonna be.
Yeah, too
it's
much.
gonna be-
But Rob too is kind of like, what did you say?
So I gotta take those like that. And like,
I'm gonna go to the
Yeah,
main
well,
room and
yeah.
summon Nanette and see if she can do this. I'll be back in a few minutes.
what's the name?
Like,
I
what?
have my credit card. Ain't gonna pop up.
Well, you have to say. Then you just-
Amber, would you want me to ask the question again?
Yeah, please.
Okay. So with the last billboard, when I ran it, I had an error which says unexpected symbol in values underscore drop underscore NA equals true. So I'm not sure what I did wrong, but that was the error I had, and I'm wondering if I'm really not sure what happened over there.
Are you getting the same error as mine? I think for some reason this one actually errors out. Are you seeing the same warning message?
Mine is a bit different.
Oh, is it good?
I can put it in the chat.
Yeah, that'd be great.
James, can you put it in the chat and it will be easier to sort out.
Thank you.
Hi, James, can you hear me?
Yeah, I can hear you.
Okay. Can you check if your parenthesis is well closed?
Okay, I'll check that.
think I just rerun it, and I'm also getting different arrow. I'll make a note of this, and then I'll try to figure out during the break.
I don't think I got an error, so let me just clarify and make sure I'm doing the right thing then. Yeah, values reorganized into one called rank. Yeah, I'm supposed to get 1, 2, 3, 4, 5. I got 7 tables come up and the artist tracks underneath. Is that's what you're expecting to run to get?
For the last billboard example.
Yeah, 7 tables come up. I think I'm looking at the right one, yeah.
Oh, I might have different versions that I uploaded to GitHub and sharing right now. Sorry, I'll try to figure that out during the break. But I'll keep you all updated. Okay, I'm gonna make a note of this. Okay, let's continue to the next example first. So earlier we talked about reshaping data using pivot wider and pivot longer functions. Here we actually have another example of converting table 2. Oh, actually, we already did this. So when we convert table between pivot longer and pivot wider, actually something we notice is that a few NA values that were implicit earlier becomes explicit when we convert a wider table to a longer table. And also we can do the same when we convert a longer table to a wider table. Some of the missing values or the NAs will be implicit. So the implicit missing values are sometimes just simply not present in the data. And for the explicit missing values, they are flagged with an A, so they are more obvious and easy, like more obvious to observe. So let's actually take a look at this example over here. So when we want to check the missing value, we can always use is.na function here. So it will return true if the cell contains missing value. So if the cell is NA. Here is a stock data frame that contains one NA value over here. So that is the return for 2022, the fourth quarter. If we use the pivot wider function, we can see that the previously we only entered one NA in the data set, but now we can see 2 missing values. So the previous implicit missing values actually becomes explicit. This NA actually corresponds to the missing value in 2022, the fourth quarter, that is this one. But this missing value actually comes from the data set as well, but it was implicit. The reason was that we do not have the first quarter for 2023. This is where this missing value comes from. So using this pivot wider function, we can observe more missing values that was implicit in the previous defined data set. We can also use the complete function. So the complete function actually takes a set of columns and then it finds all the unique combinations. So it ensures the original dataset contains all those values, and then fill in the explicit NAs when necessary. So here we passing two arguments into the complete function, so the year and quarter, meaning that we are looking at all of the unique combinations of year and quarter pair. That's why it identified 2023 actually was not in the data set. So 2023, the first quarter was not in the data set, and then it put a missing value symbol and did a return for this quarter. We can also make explicit missing values implicit. So here using these part are the same as the earlier part. Basically, we're converting, we're using pivot longer function to convert we're using the pivot wider function to convert it to this form. And then maybe we decided that the missing values are not, we do not want to concentrate on the missing values for this data set. So we can use pivot longer again to convert it back to a longer function form. So here, this part we use pivot wider, and then we use a pivot longer following that. Names 2 and values 2 are just these two column names that we want to convert it longer, that we pass in to those two arguments. And then 2022 and 2023 are actually from here, are actually the previous two column name that we want to convert it to one single column. That's why we used columns equals C 2022, 2023. So again, we drop in all of the NA values. So we put values, drop NA equals true. And the new values are stored in this return column. So in this way, we remove all of the missing values. Maybe we had decided that the missing values are not important for this analysis. So we can do something like this, and then all of the explicit missing values becomes implicit. Unless we do another pivot wider, then we can make all of the implicit missing values explicit again, like in this data frame. Another thing we can do with the missing values in R is to fill it out based on how the data is collected and why there is missing value in that column. So sometimes, depending on how the data set is organized and how the data is collected, missing values might indicate that the previous value should be carried forward. So sometimes it is called last observation carried forward. Let's actually take a look at this example. So here we define a for example of working hours. We have something like this. So we have two columns. The first one is name, second is hours. We observed the working hours for each of the person. And maybe our data is organized in a way that we did not fill out the name once it is already entered into the system. So actually these two should also be person 1, and this one should be person 2 because it directly follows this. And then this one should be person 3 observation because it directly follows person 3. In that case, we can just use the fill function. So we can fill out these two with person 1. It's like Excel when you want to fill out the empty cells. You can just drag like one of the cell down or drag the cell up. so it autofills that cell, so autofills that column, and this is pretty similar. So the default direction is down, meaning that we are dragging this person one information down these two cells. We can also change the direction to up, meaning that here we are dragging person two, we are dragging the information in this cell up till like in these two places as well. So the direction is different, but then it only depends on how your data is organized and collected. So just make sure that you know which way you want the direction to be. There are actually other directions as well. So if you want, you can take a look at the fill function. It will show you, I think, a few different options. So down, up, and up, down. Yeah, Kevin.
Hi, so this is super useful, but as part of this, and you kind of mentioned it earlier, but I wanted to come back to it. So when you're missing data, right? For example, the names make sense, right? Because you can easily fill that. But when you're missing data from like hours, right? You can't really use fill because unless it's imputing the like data, it won't really work. My question is, how does R actually think of an NA value? Is it thinking of the NA value as just a 0? So if I ran like hours, if I found the mean of hours, right, and I had some NA values in hours, would it just ignore would it just ignore the NAs and just run the ones with information, or would it treat NA as like a 0?
Yeah, that's actually a great question. So I think in R, the default is that if, for example, if we want to take a look at the mean hours for person one, if there is an NA value in the vector or in the column, it will just return NA. Unless you specify that you want to treat an NA as 0, or you want to treat an NA as the mean of other observed values, you can do that. But by default, if there's an NA, the main function will return NA.
How do I make NA, how do I tell R to treat NA as 0?
Yeah, so there are a few options. Let's see. You can fill it out. So I think there's another function to do that. You can, but it depends on how you want to treat it, because sometimes you want to just ignore that. So if you just want to ignore that, you can do that with mean of like this data frame working hour. Wait. Oh, there's no, okay, so let's define something else. 1 to NA. So this is the vector containing a missing value. And then if we just try to do a mean of NA, it will return NA. However, if you put something like mean NA and then remove NA equals true, it will just ignore this element and only compute the mean for these two. So this is the way that you ignore the NA value. Also, you can just compute the, you can try to impute the NA as maybe like a mean of 1 and 2. Then your vector will actually be 1, 2, 1.5 in a sense that you put in like the mean for previous two into this. You can also compute it as 0. So, but this one will actually bring the mean value down a little bit because you're looking at it as 0. So that only really depends on like how your data is collected and how you want to view those NAs. So that was about handling missing values and how the implicit and explicit missing values might differ and also become explicit or become implicit when we convert, when we're using pivot longer, pivot wider. So here we can look at another examples of using the pivot function. So this is a data frame for fish encounters. Here we have some of the values for different kind of fish, and then the station where we have the observation. So we only have observation when we send it. This means that these the only unique information in this third column is 1. So actually let's take a look at this. So the only unique value is actually 1. And we want to convert this into a dummy variables. So we want to convert this station information to a dummy variable, meaning that we want to make this very long data set wider. So we want to have like multiple columns, naming maybe like release or I81. So we can actually use pivot wider or pivot longer to achieve this goal. Let's take maybe 2 minutes thinking about how we can do that. And then if you have a solution, you can put in the chat. Otherwise, we'll go over the solution in a few minutes. So here, let's do it together. For this, we are actually making a very long data set wider because we want to create more dummy variables. So we can actually do fish encounters and then using pipe operator to pivot wider. So for pivot wider function, the inputs are I believe are names from and values from. Yeah, so names from, and the names from is station because we are converting this column to like the information in this column to multiple columns. So this will be station. And then the values from are the values we're gonna put in all of those. That will be scene. So let's take a look at what this one returns. So this one actually converts this very long data set to the very wide data set with the dummy variable of station being like the column names. So also, I think some of the NAs, some of the NAs becomes explicit here because previous, we talked about how implicit missing values can become explicit. We can also change these NAs to 0 because this is actually a dummy variable, so it only has 2 values, 0 and 1. 1 meaning we have an observation, and 0 meaning we do not have an observation. So we can do that via some of the arguments from here. So one useful arguments to do that is actually values fail. So if you scroll down, you can actually see all of the inputs and then the descriptions of the inputs. So If we do this, it will convert all of the NA values to 0. And here it's actually what we want, because this is a dummy variables, only there are two values, 1 and 0. So this is how we can create dummy variables with the pivot wider function. So earlier we talked about the pivot longer and pivot wider. Next, we're going to talk about the separate function. So separate function can actually help us make table 3 tidy. So table 3 is actually this one, where it almost looks like a tidy data set, except that it organized the cases and population information in the same column and the rate. So in order to make the information as effective as possible, we want to convert this column to, we want to separate this column to two columns, the cases and population. So separate can also actually do that. So here, we can take a look at the helper page for separate. But also here's a few examples. So we put rate as the first argument because we want to convert this column to two other columns, the cases and population. The default separator for this is actually the dash. I think it's dash. So these two will actually return the same result because this one is actually the default. So these two are different in the sense that we use convert equals true so that the type is actually converted. We know the cases are integers and populations are integers, but when we separate them into two different columns, it's actually stays the type as character, which is the previous type for the column ratio, for the column rate. And when we use convert equals true, we are actually converting these two columns into integers. I think that was the separate function so that we can pull the one column into multiple columns by splitting using a separator character. Also, we can combine two columns into one single column using the unite function. So here, let's take a look at table 5 first. In table, in table 5, the previous year information is actually separated into two. The first is century and the second is year. We can use this function to combine them into one single column called the year. So we define it as new year. Let's actually run this line of code and take a look at what it returns. So previously we are combining these two columns into the new year column. Here, the default, we define the separator as like an empty string, but we can also define it differently. For example, if we use underscore here, this will actually return like 90_99. But here, because we want it to be like a string with nothing in between, so we just put an empty string there. If we run the second line, these two are different in the sense that we put a remove equals false over here. So once we have remove equals false, we are actually keeping the columns that we are combining. So we can check whether this is actually a combination of these two columns if the information are the same. So we can check that by using the remove equals false. So the default is true, so it deletes those two columns. Now let's take a look at this example. So we are making a copy of table 5 as table 5.2. So table 5, the second version, is the same as table 5. Then we use this assignment operator to make this one as NA. So we deliberately change one of the cells to be NA. We can see that it is now NA after executing the second line. Now we still want to use the unite function. But if we do not have na.rem equals true, so we do not remove the na function, we can see that this is na. And then because it is interpreted a character, the new year will be a character with 19 na, which is not something we want. That's why we can use the na.remove function, so that after running this is like an empty string. So we are not looking at any of the NA values, and then our new year will just be 90. You can interpret it in other different ways, but just for the illustration of this example, we ignore the NA values when combining those two columns. So that was all of the functions I wanted to cover with tidyr. It's a useful tool and package for doing data cleaning. So I'm gonna actually take a break here for 10 minutes. I'll try to fix the issue with the notebook, and if you have any questions, feel free to unmute yourself or put your question in the chat. Yeah.
Sorry, quick question. Could you just return to the creating dummy variable efficient counter code one more moment, please? I'd just like to look at.
The dummy variable, I think it's here. Yeah.
Yeah. Okay. All right. So okay. Yeah. There's no need to have the pivot longer. Right. Just yeah. 2 pivot wide. There's no pivot longer. Just checking.
Mm-hmm.
All right. Thank you.
Yeah. Chris.
No, I had a question on this too, but you went back to it. I was just wondering how you transform the NA to zeros. So use value fill.
Which example?
No, so when you use pivot wider to make the dummy variables, the ones that are not 1 are coded as NA, right? But then in reality, since they're dummy variables, you want them to be 1 and the 1s and 0s. So in order to make the NA 0, you basically created a new object, and you said list scene equals 0.
Yes. So yeah, use the values fill equals list equals 0.
I see. Okay. So I'm a little bit confused by the code though. So you create this object values from, and then you then create values from, so scene values from, and then you say list scene equals 0. So the variable's name is scene, and then you're just telling it in that line of code that if you see this list scene equate it to 0. I'm a little bit confused by what the list command is doing.
So the list command is, we can actually run this line of code. But yesterday we used this to create a new list. So list is another type of vector. So values field, if we take a look at these is definition. So that specifies what each value should be filled in when missing. So basically it defines how you want to handle missing values in the pivot wider information. If we put something like 2 over here, that will actually replace all of the NA values as 2. So that's actually one of the ways you can use to convert NA to like other things.
Okay.
Okay, can I just contribute to that?
Yeah.
Okay, so Kevin Smith, what happens there is it converts the scene that is NA to a list first, then it changes the whole thing in that list to whatever value you set it to. It is for efficiency, so it doesn't go one by one. You first of all pick all of them, put them into a list, then change them to NA and put them back. So it's just for efficiency in running the code. And maybe you should use this opportunity to address James' code. James, I've tried to run the code. The only thing that will make the code, if the parentheses are correct, the only thing that will make the code not to run is perhaps the code you ran before that segment has changed. You assigned billboard to something. So maybe what you could try, please try to see if you can check above. If you haven't run any code that reassign, maybe pivot long or pivot wide has changed the value of your billboard if you assign it back to billboard. So by default, if you have your billboard as it is in the tidyverse, I don't see any reason why that code shouldn't run. I'm not saying you're making a mistake, but just check well. I ran it from my own system and it worked well, but I haven't run any code above it. So I'm assuming maybe something must have changed above before that line of code.
Thank you, Kevin. I'm going to rerun it from line 67 and run the whole chunk of code and see what happens.
Amber, I have a question. For separate the function, the first version of it, you didn't necessarily tell it what to separate by, but it automatically knew that it should be the slash. And I'm wondering, like, that could be tricky if we just leave it up to the function to always kind of figure that out. So is this something where we should always kind of like tell it, or how is it deciding what is the separation?
Yeah, that's actually a good question. I think for the for the separate function, it has a default. If you yeah, so actually it separates wherever it sees a non-alphanumeric character, because the separator is actually defined as this. It's not really defined as like a dash or a slash. But if you are not sure, or if you just want to be more precise, you can always put your own separator instead of using this one. Yeah, but I think in general, it looks into the non-alphabet numeric as the separator. But it depends on what your data looks like. If you are certain that all of the information are following a, like some syntax or some like some format, then maybe you can define your own. That would be more precise.
Just to add to that, thank you, Amber, for that explanation. It's always safer to put yours. What happened is that it can separate by any special character. So just imagine you have different lines with one slash, then the other one having maybe a different type of special character. Then the separation is going to run into error, because then the column will be it will be variable columns, in the sense that it won't be equal number of columns. So and if you don't understand how the function works, it might run into error. So the safest thing with R is, if need be, specify what you want. Don't let R just give you the default thing. If you can, specify what you want.
Thanks for sharing that. So I got an I think I find the reason why there was airing out earlier. I put the wrong function here. So for the last billboard example, actually that should be plus integer. Sorry, it should be plus number instead of plus integer. That was the reason that it was airing out and put all of the NAs. Yeah. So actually, the function that we used earlier was also class number from the readr package here. I'll also upload the updated version to GitHub after today's session. Okay, so let's continue with the dplyr package. So for the dplyr package, it is pretty helpful when you're doing data manipulation in R. There are a few advantages of using it. For example, dplyr is faster and it actually works well under the tidy data and database. So let's actually take a look at a lot of the helpful functions within this package. So actually the first one is the arrange function. This one actually reorders the row. So let's take a look at what these 3 lines of code returns. So here as before, we specify where this function comes from. So that comes from the dplyr package. And then we are trying to reorder the rows based on the SICSS-Howard column. So the SICSS-Howard so that is the column for the number of cylinders, and we want to reorder this data frame in the decreasing order of this column. So if we do not put decreasing here, it will actually be the increasing order by default. So the smallest is 4, and then the largest is 8. This is a default, but if we want to put it as a decreasing order, we just need to put DSC at the beginning function, and then it will reorder it based on the decreasing order of this column. We also reorder the rows using like 2 different columns. So here we are using these 2, and both of them are actually increasing by default. So here we can see at the very beginning, we use the second column, and all of them are 4. And then for all of the rows that has a 4 as the second column, we look at this third column. So this column is then reordering by the increasing function. You can also put the decreasing here if you would like to reorder it by the decreasing order instead of increasing order. But in general, the arrange function, all of these 3 has the same number of rows and same number of columns, meaning that we are not selecting any rows or we are not dropping any columns. Next, let's take a look at the filter function. So the filter function actually picks the observation by the values, meaning that either the the number of columns or the number of rows will be different. But let's take a look at actually which one is different. So here we are looking at the flights dataset. We can use the structure function to take a look at the column name and then what type of information are stored in each of the columns. So here we can use filter and choose all of the rows corresponding to January. Here we use month equals string 1 because when we take a look at the structure of it, it's actually stored as integer, but either one works. we can either use months equals plus the integer one or use the string. It will coerce implicitly and this function. So once we use the filter function, we get all of the rows that corresponds to January. So actually the number of rows will be different, but the number of columns will be the same because filtering is actually filtering the rows. We can put multiple conditions using the filter function. So these two are a little different in terms of how we use the assignment operator. So here we use the pipe. For a pipe, we are actually passing in flights as the first argument of filter. So look at here. So we filter flights is actually the first input. And then when we use the pipe operator, we can move the first input out. So this is saying we are passing in flights as the first argument of filter. Then we run filter on flights with these two conditions. So we are looking at the first day of January. That's why month equals 1 and then day equals 1. Here, I think we talked about this briefly yesterday. If we do not have the parentheses over here, this one will only do the assignment. So it will not print out what this data set looks like. But once we have the parentheses, it will do two things. So the first thing it will do is to assign this data frame to the January 1st flight, and also it will print out this data set. So it is here. So we talked about having two conditions using the filter function. These two will return the same data frame. So that means in the filter function, when you use a comma and this AND operator, it is actually the same. However, the OR operator is different. So if you want to filter out either January or December, you have to use this the OR operator here. If you put like a comma, then it will enforce the condition being both January and December. But if you put the OR here, it will filtering either January or December. So this one will have more columns, will have more rows than this one. Than this one. This is because this is a more strict condition compared with this one. And for the next line, these two are actually returning the same information. We talked about this miscellaneous operator yesterday. This is basically saying we want the month that are within this vector. So here we are putting two elements in the vector, either 1 or 12. That means we want the months to be either January or December. That's why these two actually returns the same data set. It's just the syntax is different, but you can use whichever you want. So earlier we talked about for the filter function, the number of rows will be different. So actually, one of the way we can check the dimension of a data set is to use the dim function. So here it will return the number of rows and then the number of column. It will always be the syntax. Since data frame is a two-dimensional structure, the first one will always be the row and the second one will always be the column. Here, if we use the pipe operator again, it means we are filtering the flights data set using two conditions. Either the month is January or the month is December. And after that, we are passing the results of this part to the dimension function. So we can take a look at what the returned data set is and what is its dimension. So here we can see it is slightly, yeah, it is the number of rows is smaller compared with before, meaning that we are extracting some of the rows, but the columns are the same because filtering is only filtering on the rows, so the columns are unchanged. Later, we'll talk about how to change the columns so that we are actually selecting a few columns instead of preserving all of them. So for the dim function, we said that here it returns two numbers. The first is row and second is column. We can actually extract row and column by themselves. So by using the number of row function and number of column function, we are actually getting the number of rows and number of columns separately. So if we run these 3 lines of code, we can see that these two are the same and these two are the same. So this is the chunk of code when we do filtering using some numeric condition. Next, we'll take a look at still the filtering function, but the conditions are based on characters, so basically strings. Here we will be using the Starwall data set. So let's actually take a look at what this data set contains. So this is also a very large data set. It is a table, so it has lists within the cell. The first few columns are name, height, mass, hair color, skin color, eye color. So we can perform filter function on this data set. For example, we can filter eye color, including blue. So first, we can take a look at what eye color are there in this data set. So we have a few different ones like blue, yellow, but this one is blue, gray, and we have green, yellow, and red, comma, blue. So these are actually organized differently because this is a comma and then here's a dash. So when we're filtering based on these strings, we can use this base R function. Let's take a look at its helper page first. So this one exactly search for the matches, and then it search for some pattern within the strings. So here, what this function does is it filters these eye color column and try to select all of the rows that has a blue here. So if we look at the returned data frame, under the eye color column, we only have blue, gray, which is consistent with before when we look at the unique ones in this column, blue, gray, also red, blue. So so we have two unique values here, and then red, blue is here. Also, we can filter eye colors, including blue, using another function, so the string detect function. One thing to notice is that all of these functions are passed in as an argument in the filter function. That's why we are selecting rows. So these two are actually doing the same operation and returning the same data frame. So both of them are 2114, and then both of them are returning eye color containing blue string. So the last one is actually returning the same. This one's not returning the same because we are filtering all of the eye color that are either red, blue, or blue. So this one will be a slightly will have slightly smaller number of rows compared with these two, because we are not selecting the one with eye color blue gray. So if we put blue gray also in the selector, then these three will actually return the same data frame. So we can also take a look at the third chunk of code for working with filter function. So here we are looking at this data frame. Oh, this one was defined yesterday, actually. Oh, so it was defined here. We don't need to go back to previous one. So that was the data frame when we insert an NA value. Remember, we have a missing value here that we deliberately insert into 1,3 position. So that is the year for Afghanistan for 19. So here we want to filter this toy data set with only year equals 0, 0. So we are expecting to have this line, and this line, because these three lines have year equals 0, 0. And we're actually getting these three lines. However, in the cases that we want to preserve the rows with actually an NA value, because we're not sure whether this NA is a systematic NA or it was NA because of other reason, we don't want to just remove this line in the result. So we have to put a.NA year here because this will only return true for this line. And it will return false for all other lines. So when we run those, we're actually getting 4 lines, including the NA. Yeah, Kevin, you have a question?
Yeah, I'm so sorry. So and I've been kind of having issues with this. How did you like load that Star Wars data set? So when you go back to like Star Wars, like I saw you just put the command in, but then I tried to do it and it wouldn't load.
Wow, it wouldn't. So this was actually from the dplyr package. Have you loaded this package in your system?
Oh, okay. That would make sense. No, I thought, okay, I get it now. Yeah. Okay, thank you.
So all of the data sets for the session are actually from some package from R. So you can always put a question mark and then the name of the data set to take a look at which package it come from. Yeah. Nina said that changed blue to black and got error. Which one are you working on?
But I fixed it again. It was the eye color. I had changed the blue to black. Got a bit of an error before, but that was because in the last line in line 331, I think. Well, the last line of code that looks for blue, gray, I had red, blue, and black. And so when I took out the blue, it worked. Yeah.
Like this?
So it's all good now. Yeah,
okay.
I had red, blue, black instead of just red and black. Yeah.
Oh, okay. Yeah, that was all about the filter function. So it's just to make sure that you always notice there's a missing value and you pay attention to handling missing values in R, because it's the default is maybe different in different functions. So yeah. Next we are going to take a look at the slice function. So the slice function actually chose rows by the index. So actually, let's take a look at this one as well. It's still from the Star Wars dataset. And then first, we are arranging this dataset by the decreasing order of height. So people with highest height are at the top, and then in the decreasing order. If we do not run the next line, we have we are not performing any filtering, so the number of people or the number of rows and number of columns are the same as the original data set. But now we are actually using the slice. So this function is saying that we only want the first 6 rows. Remember in R, when we put 1 to 6, it's actually including 1 and including 6. This may not be the case in other languages. So it's always good to pay attention to or run test code to see how it handles like the sequence. We can also use slice function by proportion and number. Here, for this example, we are selecting 20% of observations from Star Wars. So what that mean is that we can run this line of code. So Star Wars, and then we check the number of rows in Star Wars that will, and then multiply like 20%. This is the expected number. It's a decimal, but I think in this line, it will just chose the 17. So basically this line of code select 17 rows from the Star Wars dataset. And this is actually a random selection. So it's just make sure you put set seed with any number. So the code is reproducible. You don't get like different data set or different results every time you do like a random selection. We can also select a few rows from the Star Wars using the number. So here we put n here, meaning that we want to select 20 observations from the Star Wars dataset. Here we put replace equals true, meaning that we want to, if one row is selected once, it may also be selected for the second time. If we put replace equals false, this means once it is selected, it will no longer be considered when you select like the next row. So if you do simple random sampling, that is, you can select with replacement. So you have to put true here, but it generally depends on whether you want to select one row multiple times. There are a few other options with the slash function. For example, this one, it returns these two returns the minimum and maximum value of a variable. It basically performs a range function and then select and then slice. For example, this one using slash max height n equals 10, we are selecting the 10 people who are the tallest. And then when we use slash min height n equals 10, we are selecting the 10 people who are the shortest. Because here we are only selecting based on the rows, all of the columns are preserved. So the number of columns are the same, but the number of rows will only be 10 because we only select 10 people. Next is the select function. So select function actually are working with columns, meaning that the number of columns will be changed after you use the select function. So let's take a look at what this function does. So this line of code, we are trying to select the columns that include color in their name. So let's take a look at the Star Wars function data set again. We know these are the column names, and some of the column name are includes color. So for example, we have skin color, hair color, eye color, and we want to select all 3 columns. So these 3 columns, and we can do it by using the select function. And then we are choosing the columns that has color in their column name. So actually, let's take a look at this one. Let me run it in the console instead of in the R Markdown file. But yeah, after running this line of code, we are selecting 3 columns. All of the columns has color in their name. Yeah, so basically we use the contains function to do that. We can do that in a few different ways. For example, we used this function earlier, and here we're basically saying we want to select the columns that has height or color in their column names. So back into the Star Wars original data set, we want to select this height column and then all of the column containing color. So we have 4 columns in the result data set. These 2 actually will return the same information. So let's take a look at these 2. So both of them has 4 columns in the returned data set, the height, and then all the 3 columns containing color. So yeah, you can use either one. It depends on which one you feel more familiar. So another thing we can do with the select function is to select the columns that starts with H. So what we want is to have the height, hair color data set in the hair color columns in the resulting data set. And this one actually will do the job. So it will, we also have a home world column, so it will return all of the columns that are starting with the H. Similarly to start with, we can also specify ends with, meaning that we want to return all the columns that ends with a R. You can always use like maybe A or other strings over here, but it should work fine no matter what you put here. So this one, it returns all the column that has a R at the end of the column name. So we can actually use both conditions. So meaning we want to select the columns that starts with a H and ends with R. So we're basically combining these 2 conditions. And we are expecting to have the hair color only. So yeah, this returns the hair color because this is the only column that satisfies both of the condition that starts with H and ends with R. Another thing we can do with the select function is we can select hair color directly if we know which one we want, because this column has the name hair color, so we can just put hair color in the select function, and it will just return 1 column only, the hair color. So these 2 functions are actually different. So the difference is that we put everything as the second arguments in the select function. So using this function, we will select column hair color and move it to the first column. So earlier we have the Star Wars data frame, and hair color is actually not the first column. So once we write using this function, hair color will actually be the first one, and all other columns, we're just following the hair color column. So this one will actually return 2 columns only, the hair color and gender. This one is similar to the previous function when we use the in operator. I think it was here. It's pretty similar to this, but pretty similar to the filter function, but also this is the syntax over here that we are selecting eye color that are either red, blue, or blue. Here we are selecting the columns that has name, hair color, or gender. So actually a lot of the functions for when we work with select, it depends on which specific like function you find more familiar with. There are many different versions that you can use to select columns and select rows. So there are actually multiple solutions to the same goal. So you can work with the ones you are more familiar with. So at the very beginning of today's session, we talked about the messy data set versus a tidy data set. That one was more on the structure of the data set. But another thing we can do is to work on the messy column names, because sometimes we are getting a data set from other sources, or mostly other sources. So we can just use the janitor package and then the clean name function to clean the columns of a messy data frame. For example, here is the input data frame. We can see the column names are a little messy in the sense that they are different. This one has both uppercase, lowercase. This one are all uppercase, and then this one is column and number 3. So once we use the clean names function from the janitor package, they are organized slightly. For example, this one will become all lowercase, and then these two are actually changed to the same format, so column underscore number. So that was about cleaning the messy column names. Next, we're going to talk about the mutate function. So mutate function actually works to actually used for creating new variables based on existing variables. Using the Star Wars example as well, we can define a new column called mass height ratio. That is mass divided by height for each of the person. So here, actually, because we are only working with mass and height information, we can select them at first. Then we will only have these 4 columns because we are selecting by column names, meaning names, mass, height, and spaces. Then we are using the mutate function to define a new column called mass height ratio. That is mass divided by height. And then we can take a look at its resulting data frame. So basically, we're creating this column. It is the result of 77 divided by 172. one thing about missing value that we talked about earlier is about handling NAs in a data frame. So for this line, for this observation, because the mass is NA, even though we have height information, it will still result in a missing value when we do the division. So next, we're gonna talk about the group by function and summarize function, because these two are often used together. So I'm actually using the examples with group by function and summarize function in the same chunk of code. So here we are looking at the FLICE dataset again. So let's take a look at what this dataset contains. For example, it contains the year, month, day, departure time, and then the departure delay time, arrival time, and then the schedule arrival time. Here we are grouping by year, month, day. So basically we're looking at the delay time, the average delay time for each of the day. And here, if we just run this line of code, we can see that the average delay time for each day are all NAs. This is because if I take a look at it, this dataset actually has a lot of NAs in their depart delay column. That's why if we do not use na.rm to specify we are ignoring all of the cells with missing value, then it will basically just return an NA for this column. So these two lines are actually doing the same thing of calculating the average depart delay time for each of the day, but using na.rm, we are ignoring all of the NA values. Here, we are using the function group by, meaning that we are view each day separately. So in the original data set, we have multiple observations for the same day, but it might be for different flight or different depart time. When we use the group by function, we are actually taking the average depart time for the first day. For example, we are taking the average depart delay time for January the 1st, 2013. And in the summary function, we can actually put different attributes. For example, here we are looking at two more statistics. The first one is N, so that is the number of rows in this group. And then the N, not NA, meaning that we are only counting the number of rows for which the departure delay time is not NA. Intuitively, because there are a lot of NAs in this column, N will be slightly larger than N not NA. So let's actually take a look at this one. So this is the N column, and this is the N not NA column that we define in the summarize function. We can see that for all of the rows, this column will be slightly smaller than this column, meaning that there will be some NA values in the depart delay column. So for the summarize function, there are actually a few other summary statistics available that we can use. For example, if we want to measure spread, we can always use the median function or the standard deviation, the IQR, the math function. And we want to work with rank, we can always use the mean function, the quantile function. So this one is the 25% quantile. And then we can use the max function. If we want to measure the precision, we can always use the first, last, or the nth. function. If we want to do the cons, like this one here, we can use n, the n function, or the sum of the rows that are not an A, so only non-missing rows. So here we are actually doing cons, but based on the proportions of logical values. So logical values are the true and false value that we talked about yesterday. Here is another example when we still use group by first. So that means we are grouping all of the rows that are from the same day. So basically, these 10 lines are grouped, and then for January the 2nd, 2013, it is considered another group. So here we are still handling the missing values as we are still removing all the missing values, meaning we are ignoring all of them. But it depends on how your missing value, how you want to handle missing value. So yeah, but just make sure if you do not use NA.rm here, you're handling it in some other ways, because otherwise this will just return NA for all of the rows. So the next function we're going to talk about is the rename function. Let's take a look at the iris data frame first. So this is the famous iris data set. It gives the measurement in centimeters of variables, sepal length and width, and petal length and width for 50 flowers from each of the 3 species of iris. So right now the column names are as below. So we have these as the column name. Maybe we want to rename some of the column names to a different string. For example, we want to rename this petal length to petal underscore length. We can do that by using the rename function. So right now, this column that was previously petal dot length is renamed to petal underscore length. This one actually do the same thing, but just with different syntax. So we are using the rename function, but we are using the pipe operator. And we are specifying that the petal underscore length is the previous petal dot length. However, both of these 2 functions, they are not changing the original iris data frame. So if we take a look at the iris, the column is still petal dot length. So we should either put inputs equals true or assign this to iris over here to make sure that it is stored in your environment. Otherwise, this will not be stored and the original data set will not be changed. Next, let's take a look at the key. So key is usually refers to a unique ID for each of the rows. For example, if we do not have this ID column, then we might have some duplicated rows. For example, we might have 2, 10, 0 in the data set, and we cannot differ them. So in that case, we can use the row number as ID if there is no ID provided. So this ID will be unique for each of the row. It will be easy to access it, to look at the rows, especially when we have duplicated values in the columns. However, if the key is already provided, for example, if you are working with genome dataset, sometimes they have the SNP, then that will be unique. So you don't need to worry about the keys or the IDs you can always use the SMP as the unique ID or the key for the data frame. Next, we have the section for modeling and then plotting. I also have a few examples on some machine learning packages. Let's take a break for 5 minutes and then we will continue with the modeling section. So if you have any questions, feel free to unmute or put your question in the chat. Okay, so let's get back started. The next section is the modeling section. So for this section, we'll first talk about how to do modeling simultaneously for a data frame, meaning that, for example, if we have a data frame, actually, let's look at the example first. Here we use the Gapminder data frame. This is the data frame for the on life expectancy, GDP per capita, and population by country. So we can take a look at this data frame. So it has 6 columns and it has 1,704 rows. So these are the number of observations. It has country, continent, the year, life expectancy, population, and GDP per capita. So a nice thing about this data frame is that the type of the data frame is already converted to the type we want. For example, the year is already an integer, and then the life expectancy is a double. So these are not characters, and we do not need to convert them again. But it's always useful to just check whether the columns are of the type that we want. So here, this is the original Gapminder dataset. If we use Nest on this, we will get something new. So we will get a data frame with 6 rows and 4 columns. This is different from before. So before, the Gapminder dataset looks like this. Here because we group by country and continent, meaning we will have 1 row or 1 observation for each country-continent combination. So these two actually contains the equivalent information, but here, because we have nested by the country-continent combination, so these are unique. We will not have like rows with country and continent, but just different values in the year, life expectancy, population, GDP per capita. This way we have a more condensed data set. And yesterday we talked about the difference between a table and a data frame. So here, this is a table because we actually have a list within the cells, and this cannot happen in a data frame. So in this way, if we take a look at nested, so we are actually still look at the country column, continent column, or the data column. If we take a look at the data column, these are the tables or the list that are stored under the data under that data column. So each of the cell over here is a table containing the year, life expectancy, population, and GDP per capita data frame for each of the years. In that way, this original data set is more condensed and easier to look at. If we run nested data and then plank 1, we're basically looking like the first element. This is the same as nested data 1. Actually, it should be double bracket as we discussed yesterday about the structure of list. So these two should return the exact same table. We can always look at the table on the second line of the nested data frame. So that will be 2 as well. So these two also return the same table. And then this is the table for the second line in nested, meaning that it corresponds to Albania, Europe. And then the first one is linked to Afghanistan, Asia. So here, we can actually look at why the nest function is pretty useful when we want to do modeling for a very large data set. So here, we can actually define a linear regression model. This is the user-defined function. Here is the function name. This is the input, and then this is the body of the function. So this function, this line is actually saying we're defining a function. The input is a data frame. This is a dummy variable, so we can actually put a here. There's no difference. We put df here just as a shortcut for data frame, so it's easier to understand. For each of the input or each of the data frame that we pass into the linear model, we're actually running a linear regression of life expectancy on the year. So the data is df, so that's the input. This also means that we are expecting the input, so the df, to have at least 2 columns, which are the life expectancy and year. If we run this line of code, we're actually defining a function. So it is not running on any information. If we want to run it, we have to use lm. So we use the function name and then we put the actual input in it. So here we are applying the linear model. So this is the function that we defined above to the nested data. Let's take a look at the nested data again. So we have a table under the data column for each of the observations. It contains the life expectancy and year and GDP per capita information for this country-continent combination. So after we run this line, we are basically defining a new column called models, this column. In this column, what we stored here is a linear regression object. And then this object is actually defined via the map data linear model function. So this means we are applying this table to the linear model function. And then the result is stored here. And we do this for multiple observations. So we're doing it so this linear model is a result of running this linear model function on this table. And this linear regression object is by running the linear model on this table. So in this way, we do not need to duplicate the code or copy and paste the code multiple times. Everything is stored condensedly in this very large table, and we can always access the information within each country-continent combination to take a look at their linear regression object. So if we want to view the model result for the first observations for So for Afghanistan, Asia, we can use nested $ models, Praxis 1. So the $ is always used for accessing the columns for a table or a data frame. So here we have models. We can put 1 here, meaning that we are looking at this object. Yesterday, we talked about the difference between using double parentheses and a double bracket and a single bracket. So this is the difference because it does not have a name for this element. So if you want to directly extract maybe like the coefficient or intercept, you have to use a double bracket. So that is why we want to use nest function when trying to run multiple models simultaneously. Again, for nested data, it basically means each row is a group. And for group data, it means each row is an observation. So this is a group because it contains a table in this data column. Next, we're going to talk about the nNest function. So still we are working with this nested table that we defined earlier. It is the country content combination, and then we have a table of data that is that corresponds to this key, and then we have already applied the linear model to this data for each of the row. We can define a we can use the mutate function to add another column and then store the result in glanced data. So let's take a look at what this function does. So so the glance function from this Broom package actually inspects the quality of the statistic model. So here, if we take a look at the resulting data frame, we are defining a new column called glance here. And if we want to access this one, we can always use the $. And then if we want to take a look at the result for the first observation, it returns the linear regression model objects for the first line. So this one actually contains the same information as the model, as the models column. But the difference is that if we take a look at the first element for the models column, this is the linear regression object after we run the linear regression model on this table. So it contains the R-squared, adjusted R-squared, sigma, statistics, p-value, DF, the log likelihood, and AIC-BIC. So basically it has 12 attributes. These attributes are for the linear regression models. So earlier we used this line to access the first element of this glance column. We can always use this line as well, the blank function. It will return the same thing. Basically, they all look into the first element of this this column, so the glance column. What if we want to pull the p-value directly? For example, we are only interested in the p-value. Then we can use this pull as, function as well. So it built upon this line of code that we are look one level deeper into the returned objects. So we are only accessing the p-value. This line of code, we have like multiple ways to achieve the same goal. For example, we can use pull p-value to pull the p-value, but also we can use a $sign as well, because these result is actually a table. And we talked about this yesterday. We can always use a $sign to extract information from a table. So if we store temp as the first element in this glance column, then we can always use temp $sign p-value or temp bracket 5 to access the p-value. So these are just different ways to access the same information. You can use them interchangeably. There is no difference. So here we are actually combining the nest function and the arrange function together to look at the linear regression results. So actually, let's run this line of code first. The glance table is actually the results from earlier, where we have a country content combination. Then we have the data that is linked to this combination. We have run a model. We have run actually a linear regression model on using the information from this table. And then we use the glance function to actually look into the attributes of the model for this line, for this observation. So now we are using the nest function from the previous chunk of code. So basically it returns the attributes. And then we are using the arrange function that we talked about earlier. So it reorders the results. So it reorders the result, it reorders the data frame using the r.squared column. So because the default is increasing, the result data frame will be in the order of increasing r squared. And we can confirm it here. So the first line has the smallest r squared, and the last line has the largest r squared. You can always use different conditions to rearrange the result.
Not sure if your data says table, but mine does. I was wondering how arranging by data might go in this sense, or if it wouldn't, I wouldn't expect to see table there.
Which table?
Under the column data. So I was playing around adjusting it by different things, but when I adjust it by data, all of them say table. So I was just curious about that.
Do you mean you want to rearrange the glanced data frame by this column?
Yeah, so just like we arrange it by r squared just now, so I was toying with what to arrange it with. And so I noticed the output on the data all says table, which I know is from the original package. So I was just wondering about that, but it's all right, I guess.
Yeah, I think if you choose to, okay, so let's actually take a look at this. first. The unnested the unnested version. So this is the table before we do any arrange. Besides using r dot squared as the condition to do rearranging, we can always use maybe adjusted r squared via the same syntax. I'm not sure if we can use data to rearrange this table, but let's try and see if that works. Actually, it works, but I'm not quite sure what is the condition, like how do they compare which data is like smaller, which table is smaller over here. It is quite clear for like the other columns. For example, with p dot value column, because the information within that column is just double, so we can always compare if this cell is bigger or smaller than this cell. But in terms of this data column, the code works, but actually let's compare it. So we are accessing the first element. Okay, this is the first element, and then the second element. Can we actually see this one is bigger than or less than the previous element? So this comparison doesn't work. What about we use the double bracket? Okay, so here the comparison actually returns something is not airing out because it's doing the element-wise comparison as we talked about yesterday. But I'm not sure when we do like a range based on this data column, which one they think is the smallest. Yeah, because there's no what can we do in the decreasing order? Yeah, I'm actually not sure how they compare maybe like the data or the table for one row with another row because it contains both true and false if we do it element-wise. But this line of code definitely works. I'll get back to you on what specifically is the condition that it is implemented here. But that's a really good question. Oh, Kevin, for the code, everything that I'm using for today and yesterday are on GitHub. There are also the bootcamp videos on the SICSS page that you can always look at. So the code is actually here. I just put it in the chat. And then the textbook, I think I also sent a link to the Slack group. That is the, I'll also send it again over here. And this is a textbook. So the textbook contains a lot more information that we did not have time to cover in 2 days. But a lot of those examples and also the functions that it discussed are very useful for doing research, especially computational social science analysis. So if you have time or if you have any questions, you want to look for more helpful functions, please take a look at this textbook. If there's no other questions, we will continue to the next section on, I think, modeling and plotting. So for data visualization, the examples that I included here are using the package ggplot2. We only have time to cover a few examples. So if you have, if you want to dive into the different types of plotting, like the histogram or bar plot or scatter plot with different options, for example, with different inputs and arguments, please take a look at this book. So it has a lot more examples and we'll go into detail. So for the first example here, we are actually looking at the Gapminder dataset that we have been using. So that is a dataset with country, continent, and then the year with life expectancy, population, GDP per capita for each observation, basically for each country, continent, year. This is like the key, and then the rest is like the value. So here we are specifying what the data is, and then mapping is the arguments where we put what the information that we want to plot. Sometimes you have 2 arguments, like what is the Y column and what is the X column. But sometimes, for example, if you are using a histogram, you only need 1 input. So you just need to put maybe GDP per capita, and you don't really need a Y column here. So this function here actually defines the environment for your data and for like what is X and what is Y. But it's actually not plotting anything, because if you run it, this is just like the grid with nothing on. If we want to do a scatter plot, we can put this P that we define using ggplot plus geom point that will return a scatter plot. But because we haven't specified anything else, it will just be a scatter plot with each black dot representing a life expectancy GDP per capita combination. if we want to fit a line to our scatter plot, we can use plus geom smooth function following like this line of code. So this function actually calculates a smooth line, and the gray area, so the gray area around the blue line is actually the confidence interval, so the standard error for the line. We can see that as the data points become scattered, meaning that there's a lot of data points over here, and then there are fewer data points over here, the standard error actually increase. This is actually intuitive because when you have less data points, the standard error will increase because every time you add a new data points or you remove a data point, the resulting value will be quite different because each data points have a very influential effect on the overall shape and overall linear regression of like this fitted line. So here, the method under geom smooth is the GAN method, but you can always, using your own formula, for example, you can define a linear regression model under geom smooth. But there's also like other different methods that you can specify here using the geom smooth. The second example comes from the same textbook. It's using the same data set and the information are the same. However, what is different is that we are using size equals population and color equals continent. With these two arguments, here we can take a look at the color of the points. So earlier it's just black, and now each color has represent different continent. Also, we have the size of the scatter plot being some of the very big points and some are pretty small. So the smaller points represent a smaller population, and the larger points like this one represent a larger population. So this will give you more intuitive understanding of what is the trend of the GDP per capita versus life expectancy. Maybe there's like some area with a lot of European countries or a lot of countries with very large population are stacked in this area. A lot of the countries with very small population are usually grouped in this area. So it will give you more information that you won't be able to see with this very basic plot. So the next plot is also pretty similar to the previous two plots. These are just based on the same information. So we all have X equals GDP per capita and Y is the life expectancy. But here we are adding a few other information. For example, we use alpha equals 0.3. So these are not, the color is not as deep as before. And then we can specify the method under geom smooth. Also, we are adding a few labels. So for example, we are adding the title. It is the gapminder plot. And then we have the subtitle. So that's the data points are country years. We have the caption at the right bottom corner. So once we have plotted, we can save this picture using the ggSave function. So if we take a look at the current file system, I'm saving it under images figure example.png. So it's actually here. This is where it's saved in my laptop. So the next example is a tree example. I also use the training set and testing set in this example. So here we are looking at the car seats data set. The car seat dataset is from the ISLR2 packages. It is a simulated dataset containing sales of chilled car seats at 400 different stores. The structure of this dataset is as follows. So we have a few different, if we have 11 variables, for example, the sales, and then the price charged by competitor at each location, the community income level, the advertising level, the advertising budget, the population size in region, and then the price company charges for car seats at each site. So here we are trying to do a classification of to predict whether this observation has high in the sales. So because we want to do a classification, it's not like a regression. We want to convert the sales information to a categorical. So it's like a factor or a qualitative instead of a quantitative random variable. That's why we're using this factor function that we talked about yesterday. So if the sales for the observation is less than 8, then we will denote it as no. If the sales is greater than 8, we will denote it as yes. So the sales is the unit sale in thousand at each location. So we're actually comparing whether the sales is high or not. So this is the response will be a factor with 2 levels. Here we are using the set seed function again, just to make sure our code is reproducible, because we are using the sample function. And if we do not have the set seed function, it will return different results every time we run this chunk of code. So here we are using the sample function to split observations into a training set and a testing set. So here we are selecting 200 rows from this car seats data set. And then we define the training set. Oh, actually, we're defining the test set first. So we are defining the test set as all of the rows in the car seats data frame that are not the train rows. For example, the train. Oh, I haven't run this yet. So the train variable that we defined here is a vector. So it contains the row numbers that we are selecting for our training data set. Here we are defining the testing data set. Because we use this syntax, it basically selects the rows from car seats already. It is not just the index, it is the observations. Now we can select the response variable for our training data set. So high is the response variable for all of the car seats, and we are selecting the ones that are not in the training set. So basically these are in the testing data set. We can take a look at the high.test. So that will be a factor including 2 levels, yes and no. And then we can actually build a tree using our training data set. And then we can exercise, we can evaluate our tree model by running the model on our testing data set. So here we only separate the data into training and testing. When you are doing your own analysis, you can always split it into training data set, testing, validation. So let's take a look at the results after running the tree model. So here we group the results into a table. On the left-hand side, this is the predicted result. And here on the top right, it is the actual result. So we can take a look at how many correct predictions we have using our tree model versus the actual result. So what this 104 means that we predicted the result to be no, and the actual result is no. So this is predicted correctly. And this one is also predicted correctly as our prediction is yes, and the actual result is yes. So we can take a look at the what percentage of predictions are correct. So that will be 104 plus 50 divided by 200. That's the total number in the testing data set. We can also plot it. So this will be the tree structure for our model. This is based on the trained data set. Here is saying that I didn't add the text here, but it will have a binary result whether the condition is met. If the condition is met, we go to this line, and if the condition is not met, we will on the other hand side of the tree. So after building this tree, we can also improve the prediction via cross-validation, either tenfold cross-validation or like other type, like to change the to find the optimal level of tree complexity. So this one is a pretty complex tree already. We have a few different branches. We have a lot of levels. So if you want to make this may not be the optimal level because we already specified here. Next, we have one last example on the time series data. So this example is actually come from the book Forecasting Principles and Practice. This book is a textbook for working with time series data. So if you have time, you can also take a look at it. So for the first line, we're actually filtering the Austratel dataset based on the serial ID. So ID is like the key that we talked about earlier today. We are only choosing the lines with this serial ID, and we are plotting its behavior using the pipe operator. So we can take a look at this. And then for this one, it's actually doing filtering as well, but then we are also doing a few modeling and forecast. For example, this forecast is the prediction for in 2 years. But these are all the functions, I think, from the FIBO package. If you are interested in time series data or if you're going to use it in your own research, you can take a look at the full documentation for this package. Here is another example on time series data. So basically the format of the syntax of running time series analysis, it's pretty similar to before, but the packages and the functions are different. For example, this is the ACF function. It's specifically for time series data, but then the labs, for example, we can add the subtitle. We can also add the title. Those are pretty similar as before. So yeah, and then this is the resulting ACF plot. We only got one lab that is outside of the blue, like the interval. So that actually tells something about the time series data. It's some of these attributes, and then what's its shapes look like, how we can predict the future stock prices for Google. I think this will be everything for today's session. Yes, Arvin, I'll go over the schedule after our workshop. Oh yeah, Kevin, do you have any questions?
Yeah, Amber, sorry, I just had a quick question. So for like machine learning topics, what book or resource would you recommend?
I think it actually depends on what specific research topics you're interested in, like what types of data you're working on. But in general, I would say maybe start with the textbook for like the computational thinking for social scientists, and then some complementary machine learning textbook. For example, this one, it has a few examples in R, so it's also a good place to start. Although this book is a little heavy on the mathematical background, so it also goes over a lot of derivations on why we use maybe this distribution versus another. But it also has like a lot of examples as well. So if you want to take a look, it's a good place to start. Yeah. Also, there are a few textbooks focusing on Python, but it really depends on which language you want to use. If there's no other questions, I will go over the schedule for tomorrow's session, and then we can go back to the main room. Okay, let me find the schedule. So I think tomorrow is actually the official day one. We will meet at 10 to 10:30 a.m. Eastern time for the introduction logistics. And then from 10:30 to 11:30 Eastern time in the morning, we will have a small group discussion. Then it will be followed by a 30 minutes break. From 12 to 1 p.m. Eastern time, we will have the live Getting the Most Out of Your SICSS-Howard Mathematica experience, a roundtable discussion with SICSS-Howard Mathematica alumni of color. Here are the information for our speakers of this roundtable. From 1 to 1:30 p.m. Eastern time, we will have another break. And from 1:30 to 1:45 p.m. Eastern time, we'll have the introduction to a group exercise. Then from 1:45 to 2:45 p.m., we'll have a group exercise continuation where you will have a case study exercise, and you will discuss that in a smaller group. So after the small group discussion from 2:45 to 3:15 p.m. Eastern time, we'll have a whole group debrief about your case study. From 3:15 to 3:45 p.m. Eastern time, we'll have a debrief and logistics. So after the debrief from 3:45 to 4:15, you'll apply for data access for Fragile Family Challenge activity if you haven't done already. And then we will have another 15 minutes break, and then we'll close out by the SICSS-Howard Mathematica kickoff and opening plenary from 4:30 p.m. to 5:30 p.m. Eastern time. So that would be the schedule for tomorrow. I think we will all go back to the main room, and if you have any questions, you can stay a little bit longer, and I'll be here for a few more minutes. Yeah, thank you, everyone.
Thank you all for watching. For more information on SICSS-Howard Mathematica, visit our website, follow us on social media, and join our email list.